As we begin Chapter 5 today, I want to make just a few comments before we launch into this. This chapter is one that has some of the building blocks that will be needed for portfolio management and to cover some portfolio theory in Chapter 6 and then to be able to complete a project that we'll do a little bit later on. As we start into Chapter 5, I'll just say this to you. I would encourage you to read through the chapter and then go through this practice exercise and get really comfortable with the numbers. My expectation is that you'll be able to understand not only the theory but exactly how the math works for a lot of the calculations that we'll do. And you will need these in order to move to the next level. As you go through this, at first it may seem a little bit intimidating, but I think as you get into it you'll find that it's really not that hard, that in fact it's quite intuitive. Students, as they jump into Chapter 5 and they read the chapter, get a little bit intimidated by it, but once they actually work through a few problems, they find that it's really not too bad. And the thing that I'll say to you, if this gives you a glimmer of hope here, is that if you can get comfortable with the material in Chapter 5, then as we move into Chapter 6 and move into portfolio management, you'll really enjoy it. And in the end, you'll be able to build a very impressive model that you can take home and even use in your personal life. So to begin, click on this. Go to this page. I'm assuming that you're already here, given the fact that you're listening to this video. Click on the link that pulls up an Excel template. I have given you a password in class before. Use the same password, and when you're done, you will come to this sheet. Now on this sheet, as you look at the bottom, there are a whole bunch of pages or sheets, each that cover a different topic coming out of Chapter 5. So on this first one, what I'd like you to do is calculate the holding period return of a stock. Let's suppose we bought a stock at $50. A year later, we sold it at $60, and we also received a $4 dividend. What is the holding period return? Now, I'm not going to give you the formula, but I'll just share with you something we have talked about in class before. Whenever you want to calculate the holding period return, the way that I remember it very easily is, in my mind, I say it's dollars earned or dollars lost divided by original dollars invested. So think about this problem right here, and you could exactly figure out the formula if you consider dollars earned divided by dollars invested. Quickly calculate the holding period return in that cell. If you calculated this correctly, you should get an answer of 28%. If you're not sure how to do it, work with your neighbor or go back and refer to the chapter. Let's take the next sheet. The next one, we're going to talk about averages. Now in the business, a lot of times people will say, calculate an average for me. What I want you to understand, there are many ways to calculate an average. There's not just one way. And once you get out there, if somebody says, oh, I calculated the average, here's the value, it would be important for you to ask them which methodology did they use, or what average. Now there's two that I want to address in this chapter. One is the arithmetic average and the other is the geometric average. The arithmetic average is the kind of average that most of us think about. So let's look at this. I have in the first quarter a 10% return, second quarter a 25% return, third quarter down 20%, and fourth quarter up 25%. So if I said to you, what is the holding period return over those four averages, most of us would say add up these numbers and divide by 4, or we would use the Excel function average, and we would simply calculate the average, and we'd say, oh, the average is 10%. That type of average is an arithmetic average. I now want to briefly talk about what a geometric average is. To introduce the topic of a geometric return, I want to just show you an interesting relationship. Some of you may already know this, but let's just review it quickly. If I want to calculate the future value of something using kind of the longhand mathematical method, here's what you do. I'd say the future value is equal to some dollar amount, so let's say $100, times 1 plus an interest rate, so let's say 10%, raised to the power of however far you want to go into the future. So if we want to go forward 4 years, I'd raise it to the power of 4. So if I want to figure out the value of $100 4 periods from now, I'd take $100 times 1 plus the rate raised to the power of 4. Okay, hopefully that rings a bell somewhere from your past. So I want to show you something else now. If I say 1 plus 10% raised to the power of 4, I want you to know that that is identical or equivalent mathematically to saying 1 plus 10% raised to the power of 2 times 1 plus 10% raised to the power of 2. And that also is identical to saying 1 plus 10% times 1 plus 10%, times 1 plus 10% times 1 plus 10%. Mathematically, those are all saying the exact same thing. So this is my point. In this next formula, where we want to calculate the geometric average, we have the following. In the first quarter here, we have 1 plus 10%. That was the return in the first quarter. In the second quarter, we're saying that we had a 25% return, so we'll say 1 plus 25%. And in the third quarter, we were down 20%, so we'll say 1 minus 20%. And in the fourth quarter, we were again up 25%, so we'll say 1 plus 25%. Hopefully I'm not off the board there, or off the camera, but that's the same as saying the example where we said 10% for 4 periods in a row. Here's 10% in the first period, 25% in the second period, down 20% in the third, and up 25% in the fourth. Now this is what we're trying to solve if we're calculating a geometric return. We are trying to say the following. We're saying 1 plus some rate raised to the power of 4 is equal to this equation. In other words, we're saying if you had some rate, what average rate, if it included compounding and raised to the power of 4, would be exactly equal to the average of all those with compounding worked in. And mathematically, we can solve that. Get rid of this so it doesn't make it confusing. Here's how you mathematically solve this problem. The first thing we want to do is we have to get rid of the 4. What we're trying to do, if you look at this carefully, is we're trying to say we want to look at the rate and have the rate alone and then algebraically manipulate everything and say, you know, what equation, if we applied all this, would give us this average rate. So the first thing we have to do is get rid of the 4. And the way you do that is you can multiply both sides. So let's multiply both sides by 1/4. Got that? So if I say take 4 times 1/4, and on this side I'm going to raise this to the power of 1 divided by 4. I'll put little brackets around it. I'll raise that to the power of 1/4. Let me just rotate this camera slightly. Can you see that there? Then I can look at this and I can say 4 times 1/4 is 4/4, and 4/4 is 1, and if it's 1, I've just taken care of that. I've gotten rid of that thing. And then I'm saying 1 plus the rate is equal to this equation. Essentially, if you look at this carefully, we can take the brackets away now and subtract 1 from both sides. And if we do, I'll put another bracket in here, and I can say subtract 1. And if I subtract 1 from both sides, I've got that. Let me turn the camera just a little bit, and what you end up getting here, hard to kind of see it, but what I've got here is I say the rate is equal to 1 plus this rate times this rate times this rate times this rate. I take all of those, I raise them to the power of 1/4, and when I figure out that answer, I subtract 1 from it. That's what the end's saying, and I will come up with the average rate, the geometric average. So I want to work this through on our computer and help you get comfortable with it. So coming to our computer, Again, what we said is if we want to figure out the average compounded return of these 4 periods, we do the following. We say 1 plus the rate in each period. So that's 110%, 125, 80, and 25. And I copied that down. 1 plus the rate in each of those periods. That's the first thing we have to do. And then, after we said 1 plus each of these rates, we then said take the product of these, this times this times this times this, and we said raise it to the power of 1/4 and subtract 1. So let's do it. If I want to say this times this times this times this, there's a product function in Excel called product. I can say take the product of all of those, raise it to the power of 1 divided by 4, and when you're done, subtract 1, hit enter, and my geometric average is 8.29%. So basically what I'm saying to you is if you took $100 and invested it at 10% for this period and then received a 25% return in that period and then reinvested the money again the next period and had a 20% loss and then reinvested that and had a 25% gain, the future value of all of those would be identical to just saying if you invested $100 at 8.29% for 4 periods, you'd have exactly the same future value. I'll work through an example in just a second. But let's go back on this. I said the product of each of those raised to the power of 1/4. This 4, we came up with the number 4 because there were 4 periods. Let's suppose I had 1,000 data points there. If I had 1,000 data points there, I'd hate to have to go count them all up. So one thing you can also do is you could highlight this and you could say I want to use the count function inside there. And when I use my count function, I'm going to have it count up the number of data points. So when it says count, it will count up 4 data points. So I'm kind of saying take the product of 1 plus all those numbers, raise it to the power of 1 divided by the number of data points minus 1. And if you get that set up correctly, I've got 8.29. And then it's easy if you've got 4 data points or 1,000. But let's work through a quick example here. Suppose I had $100. If I took this $100, let's see, how do I want to do this? What I'll say is this. I'll say I've got $100 there. If I took this $100, you don't have to do this, but if you just want to conceptually follow me, you can, and if you want to do it, go for it. I have $100. If I want to take the future value of it, I can say times 1 plus 10%, and if I raised it to the power of 1 like that, or I took it out, it gives you the same answer. But $100 with a 10% return 1 period later would be worth $110. So look, if I said take that $110 right there for the next period and grow that at 1 plus 25%. So grow it at 25% for 1 more period. At the end of the second period, I'll have $137. If I then said take $137 and invest that now at 1 plus a minus 20%, 1 period later, it would be worth $110 again. I'll format this. And then if we took that $110 and we said let's invest that at 25%, we would have at the end of the 4th period $137.50. So you can see that each of those rates, if $100 had been reinvested at each of those rates, in the end I'd have $137.50. Now watch this. If I just simply said take $100 and invest it at 8.29% for 4 periods. 4 periods later, I would have $137.50. So intuitively, this is what I'd like to say to you. The geometric average figures in the compounding of interest. Interest on interest, things being reinvested at the next rate. The arithmetic average does not. The arithmetic average is simpler, but it's not, in my mind, as accurate, at least in this context, in the context of reinvesting money over and over again. And just for your information, mutual funds, when they calculate an average, they always show you the geometric average. It's a standard we use in the business. So that if you were to put your money into a fund and invest it, and then at the end of that period, whatever your returns are, if they were reinvested and so on, and this kept going forth, you would be able to get a handle on what your average is, and the average they present to you is a geometric average. Now I'm saying this to you because as we go forth in this class and we talk about averages, in your mind understand that an average, one average may be different than another average. And in this context, mutual funds use geometric averages, and a lot of times in regular life we use an arithmetic average. Let's now